Next up, we have Shabnam Gupta, who's going to speak on bicuspid aortic valves and how this congenital condition influences hemodynamics in the affected patient.
Okay, hi, my name is Shabnam Gupta, and I'm from Dr. Yoganathan's cardiovascular fluid mechanics lab. I'm just going to talk a little bit about my work with bicuspid aortic valves and how the hemodynamic assessment of them can be used as a clinical diagnostic tool. This is just to start off a little bit of background about the heart. There are 4 valves, and my project revolves around the aortic valve, which is the valve in the center. These pictures show the closed and open positions, and the role of the valves is to direct blood flow in a single direction through the heart. And this picture shows the aortic valve in more detail. It's composed of 3 pouches or cusps, and they meet at the sinotubular junction. And the top part is the aorta, which directs the oxygen-rich blood from the heart to the rest of the body. So it's a very important function in our bodies. There are 2 primary geometries associated with this valve: the normal valve with 3 cusps, and bicuspid valves, in which 2 of the 3 cusps have fused together. And this allows less blood flow through the valves, and it can lead to many different conditions that are not very favorable for patients. So a few people, famous faces who have bicuspid aortic valves: Robin Williams, Barbara Bush, Arnold Schwarzenegger. They all had these valves replaced by surgical procedures, which are a pretty invasive and high-risk procedure. So my project is working on trying to reduce the risks associated with this. And so there are 3 primary geometries associated with bicuspid valves, and the different conditions that occur with a diseased valve, as shown in the right image, are valve stenosis, so not enough blood can flow through, and regurgitation, so blood flows in the wrong direction. And 1 to 2% of the population in the U.S. are diagnosed with this condition, and they're often asymptomatic for years and not diagnosed until later in life, which can lead to problems because the stage is so advanced where surgery is the only option. So first of all, we're trying to use echocardiography machines, which are the standard of care for clinicians. That's the main machine that they use in diagnosing this disease. So to keep everything consistent, we're going to use that same equipment to apply it to valves in a flow loop. And this will be done by extracting a valve from a heart and placing it on a stented ring, which will then be placed in a flow loop. And images can be obtained in different parts of the cardiac cycle, which will be represented by controlling conditions in the loop. So how do we actually obtain these valves? We take a heart that's obtained from a local farm, and it's a porcine heart, so it comes from a pig. And we extract the valve, and then we suture it or sew it onto a stented ring. And this is a picture of a heart. It's about the size of my hand. And then the aortic root, at the base of the root is the actual valve, and the little flappy area at the bottom is what we use to sew onto the stented ring. And that ring is then placed into a chamber and hooked up to a flow loop. That's a picture on the right of the stented valve, and it's a pretty laborious task. It takes a lot of. I haven't quite gotten the hang of it yet, but it takes a bit of skill to get used to. And once the picture on the right is the chamber that we use to house the valve, and then it's hooked up to this flow loop. And inside the flow loop is water glycerin solution, which mimics the viscosity of blood, so that we can get a more accurate representation of how the hemodynamics in the actual human body is. And the echocardiography machine that we use is shown here with a pediatric probe. And the reason for using the pediatric probe is we can get a more clearer image because we can obtain it closer to the actual valve. And the gel is used to block any bubbles from appearing in the pictures. And this is a tell that there's a lot more stress involved. This is just a comparison of two different